Starship is successful in its fourth flight. Starliner reaches the station carrying people. Hubble is down to only one gyro at a time. And Chang'e 6 scoops samples from the moon and heads for home. All this and more in this week's Space Bites. All right, buckle up. This is going to be a big episode of Space Bites. There's a lot of news that we have to get through. It's one of the busiest space news weeks that I think I've experienced in a long time. So first up, we've got to talk about the launch of Starship. The goal this time is still the same, to demonstrate that you can launch the Super Heavy with the Starship on top, that Super Heavy can detach, boost back, and land gently in the Gulf of Mexico, that Starship can carry on to orbit, then it can re-enter the Earth's atmosphere, and then also land safely in the Indian Ocean. And so this was the fourth test. Were they going to pull it off? We saw all the different ways this mission could go wrong in the past, and now this is it. So there's a one-day delay because of weather, but then we saw the launch of Starship on Thursday, June 6th. And I've got to say, they really have nailed the cameras on the launches now. There was like some kind of drone shot that watched the rocket pass right by, and it looked really, really cool. Shortly after launch, within a couple of minutes, we had that booster separation. We got the hot fire ring detach from Super Heavy and went off on its own. And then you saw Super Heavy make its boost back. It glided for a while and then was able to return, oriented itself, and slowed itself back down to a stop just above the ocean, and then fell into the ocean. Fell over on its side, and I'm guessing is now sitting at the bottom of the Gulf of Mexico. Starship continued on and went to orbit. And then we got this very long loss of signal while they played the Blue Danube Waltz, I believe. And, you know, what were they doing during that time? I think Anton has his theories. Perhaps something from 2001, I'm not sure. But when the feed came back, the spacecraft was on its way for a re-entry trajectory. And this time, it wasn't flipping around, it wasn't changing its orientation, it was just rock solid in the perfect angle for it to re-enter the atmosphere. We saw, as it started to go through the atmosphere, we saw more and more of the plasma heating up around the spacecraft. We heard various important points along that descent trajectory. It had reached the point of maximum heating on the nose. We heard that it reached the point of maximum pressure. And as the pressure was building and as the heat was building, we started to see some damage from the reentry. We could see that various heat tiles on one of the flaps were starting to burn away. Pieces were starting to vaporize. And unfortunately, then the camera got clogged up. And so we weren't able to like perfectly see. We could sort of see little spots in between where there were these marks on the camera, and then the camera lens cracked. So it was a pretty difficult re-entry, and yet we could still see the telemetry all the way down. I think the part that really amazed me was how they didn't lose signal more than just a couple of seconds for the entire re-entry. And we've never seen this before. Like, normally when a spacecraft passes through the Earth's atmosphere, you get this plasma heating around the spacecraft. That interferes with radio communications and no signal is sent out. And so you have to just like wait to find out if everything worked okay. But amazingly, Starship was able to maintain contact with Starlink, be able to broadcast pretty much its entire re-entry. So then the speed slowed down, the pressure reached sort of its maximum point, and then it was in free fall. This was sort of a part that I wasn't sure was going to come together, but it worked okay. It was able to reorient itself, put itself into that belly flop position, and then just as it was getting close to the surface of the ocean, it reoriented itself, fired its rockets, slowed itself down, and again, just sort of hovered right above the ocean and then gently went into the ocean. And again, the camera was down, so you couldn't quite see what was going on, but you could see the sort of the flash as the rockets were firing and they were getting close to the ocean. You could see this huge hole on the side of the fin, and yet it was still able to perform this final maneuver before it went into the ocean. So I think, you know, for all of the previous ones, they were various levels of success and failures. This one feels like a complete success. Like, this was the goal. They were able to complete each part of their priorities. They They demonstrated that Super Heavy can boost back and land. They demonstrated that Starship can survive re-entry through the Earth's atmosphere and be able to safely land. And so now comes the refinement process where they try to fulfill the full objective of a fully reusable two-stage rocket system. So think about the tasks that are left to do. One is Super Heavy can't land in the ocean. It's got to land on the actual launch tower with those chopsticks and be able to sort of safely be held. And of course, if this goes wrong, then it takes out the launch tower. That's a gigantic setback. Now, they said they're building a second tower, so there should be 2 towers in both Texas and in Florida. They disposed of the hot fire staging ring on this launch. They say that's just temporary. They're going to go back to something that is fully reusable, so we'll see that get integrated. Also, Starship has to land safely at the tower so that it can be reused. And then the big issue is that re-entry. I mean, we saw the damage that that plasma and pressure were doing to the heat tiles. It was tearing the rocket's outsides apart. And, you know, we don't know how much of it actually survived, and we might never know because now it's at the bottom of the Indian Ocean. But the next few missions, they're going to have to see what that kind of damage is and then figure out how to reinforce the exterior heat shielding of the spacecraft so that it can be reusable in some kind of timely manner. Because if they don't get that done, then this thing is just going to take months of refurbishing to get to the point where it can then be reused for another mission. And that goes away from the whole goal of a fully reusable two-stage rocket that's rapidly reused. They made a side mention that they've built a new factory for Starships, that they're planning on pumping out 1 Starship a day when they reach their full capacity. So who knows? Maybe that's not even going to be required. At this point, you've got an incredibly powerful rocket capable of delivering enormous payloads into orbit. And even if both parts are not fully reusable, this is new territory. And then hopefully everything from this point forward is going to be gravy. So congratulations to everybody involved. The clock is ticking to get this all operational for the Artemis 3 mission. So although you can be happy with your success, there's lots of work to do. Starliner took humans to space. Just a day before we saw Starship launch, there was another big mission that was in the works, and this is the Boeing Starliner. This is the other way that NASA is hoping to get astronauts to the International Space Station. We've seen the SpaceX Crew Dragon working for several years. Can Starliner fulfill this mission as well? We had the 2 astronauts show up at Cape Canaveral, Butch Wilmore and Suni Williams, and they got into the seats a couple of times in preparation for launch, but then the launch was scrubbed and delayed. But finally, on June 5th, the rocket took off. And leading up to this launch, NASA was concerned about a couple of things, but one was there was a leak of helium inside the spacecraft. And this helium is used to be able to push propellant from its internal tanks to its thrusters. And of course, you know, if it isn't able to do this, then it isn't able to change its orientation, and this could be a problem for docking operations when it reaches the International Space Station. So the launch was flawless. You saw this amazing takeoff on an Atlas V rocket with 2 strap-on boosters. They detached, the upper stage carried it further, and then the capsule was put into orbit. And then the astronauts spent 26 hours catching up with the International Space Station. Once they were in orbit, the astronauts tested out some techniques. They tried taking over manual control of flying the spacecraft, and that all apparently worked well. But the helium leak showed up. And so NASA was keeping an eye on this leak. They didn't think it was a giant concern, but still not a thing you want to see happen. And then we saw the docking of the spacecraft to the International Space Station. But the docking didn't go perfectly. There were some minor thrusting problems as they were approaching. And so when you add all that up, you've got the thruster problems, you've got the helium leaks. I think there's probably still a lot of safety work that's going to be done. And so it'll probably be a little while before we see that next launch of Starliner. But still, it's exciting now that NASA has 2 ways to be able to send its astronauts to the International Space Station, like just in time to deorbit the space station. Is that too mean? China lands on the moon and launches back up with samples. In the midst of all of this rocket news, we got a successful landing on the moon by China's Chang'e 6 sample return mission. And this is exciting because the mission landed on the far side of the moon. In addition, its job was to retrieve a sample from the surface of the moon. It actually had a drill on board that allowed it to drill down 2 meters into the regolith on the moon, collect up a bunch of samples, about 2 kilograms, which it then put onto its ascent module, which then flew up into orbit, met with the return spacecraft, and is now on its way back to Earth. If all goes well, the samples should re-enter the Earth's atmosphere on June 25th. And this is important for a bunch of reasons, that we're seeing the first samples from the far side of the moon. And of course, hopefully this is going to contain larger amounts of water ice mixed in with the regolith. But the far side of the moon has like a different history geologically than the near side of the moon. And so hopefully geologists will be able to piece together some of the missing details about how the moon formed. And of course, this is a perfect dry run test for a future mission that will send humans to the moon, where you are flying to the moon, you are landing on the surface of the moon, you're getting out, you then have an ascent module meeting with a return capsule and bringing humans back. And so China continues to be on track for sending humans to the moon by the end of the decade. dearMoon is no more. Speaking of missions to the moon, we learned this week that the dearMoon mission has been canceled. This was the private mission by the Japanese billionaire Yasuda Misawa, and he had announced that he was going to fly a SpaceX Starship around the moon, kind of like an Apollo 8 mission or an Artemis 2 mission, and he was going to take 10 creative types with him, poets, musicians, YouTubers who focus on space exploration, with him around the moon, and then return back safely to Earth. And I guess originally this was supposed to happen at the end of 2023. Here we are in 2024. SpaceX is still working through being able to even bring this thing successfully back down to Earth. And so obviously there are delays, and I guess for Misawa, that was too much delay, and so he canceled the mission. Now, this came as a surprise to all of the participants. They had no warning that this was gonna happen. And the general sense is that there wasn't a lot of patience here, that it was announced just 18 months ago. SpaceX missions take longer than you expect, and so it's not surprising there's gonna be significant delays to when this would actually happen. And yet, it's assumed that eventually this spacecraft will be human rated, capable of being able to fly out around the moon and return to Earth. And so it's weird that he canceled it so quickly, but it's his money. Slim is finally dead. Now, every month I've been regaling you with stories about the Japanese Slim lander and how once again it has restored contact with Earth. And this is like against all odds. The spacecraft landed upside down. Its solar panels were mostly pointing away from the sun. And so it had to wait till the very end of the lunar day that sunlight could finally get into its panels. It woke up, send a message home, send a picture, and then sunset. And then it goes back to sleep again for another lunar night. And so the Japanese Space Agency was waiting to hear from Slim, and they didn't. And so it's assumed now that the mission has finally died. But they're gonna try again in a month, and I'll let you know if they hear anything. Every week, we do a vote on our channel where you tell us what you thought was the best story of the week. And the winner this week was that James Webb saw the most distant galaxy ever. So thank you everybody who voted on the channel. Now we post this new vote into our community tab within 24 hours of when we release this Space Bites, so you'll know when you can vote. But if you're just scrolling on YouTube and you see our vote, go ahead, take a second. Tell us what you thought. And of course, the best chance to see this vote is to subscribe to the channel, click on the notifications bell. Hubble is down to single gyro mode. A couple of months ago, I let you know that the Hubble Space Telescope had gone into safe mode because it was having some problems with its gyros. And then NASA worked through the issue, brought the spacecraft back into science operations, but it looks like this problem isn't going away. Now, a bit of history here, right? The Hubble Space Telescope needs these gyros to maintain a very accurate position when it's looking at a new target. It started with 6 gyros, and they were swapped out during the last servicing mission in 2009. So it had 6 fresh gyros, but we know these things go bad. A couple of years ago, NASA tested out an idea called single gyro operation. And they knew that there would come a day when Hubble would no longer have the 3 gyros that are ideal, that it would be down to 2 or maybe even 1 gyro. And so they tested out, is there a way that we can actually make this telescope point with only a single gyro? And they found out that they could. Now, it's a slight reduction in the amount of science that they're able to do, about 12%, and yet they can operate with just this single gyro. And so Hubble is down to 3 gyros, 1 is not working, and so NASA decided they were going to make the change and switch over to the single gyro operation mode. Now they've got single gyro operation mode, and they've got another gyro that they're keeping as a spare. So when this one fails, they can switch over to the other one, and that they hope will get them through to the mid-2030s. Now you've probably also heard that a private company has proposed doing a private servicing mission to boost the orbit of the Hubble Space Telescope, maybe swap out those gyros and give it decades more life. And this week we learned that NASA has decided not to take up this offer. Obviously that sounds strange, like why not let a commercial company be able to service Hubble and get it back operational? But the problem is, like, when they originally did the servicing missions for the Hubble Space Telescope, they have the robotic arm. They were able to fly close to Hubble, reach out with the robotic arm, bring it close, and then the astronauts were able to perform all the servicing. NASA's concerned that, say, if a Crew Dragon tries to do this mission, it's going to get very close, it's going to be releasing volatiles, those could get on the mirror, and it could do more damage than it would improve the lifetime of the telescope. And so this is something they want to approach very carefully. And so they're waiting to decide whether or not they want to be able to do this. But they haven't ruled it out forever. So it may come some time when Hubble is down to 1 operational gyro and they decide, well, why not? We'll see what happens. Testing the new moon suits. We got a couple of cool pictures this week from various astronauts testing out the new Artemis 3 moon suits. These are being developed by Axiom Space, another of these public-private partnerships. And so NASA got their hands on the actual moon suits, and they had some astronauts actually test them out on a couple of trial operations. So one is they had them work with a mock-up Starship airlock. This is the airlock that the astronauts are going to use when they arrive at the moon. They're going to have to be able to go into this airlock, pressurize their suits, open up the exterior, go outside, get into the elevator, go down to the surface. And we saw this test of each of those components. They actually pressurized the suits to see how well they were able to work and perform some of their functions while they were actually wearing these new suits. So we're still early days, and obviously, we're not going to see a launch until 2026, but still, like, time is running out to get all of the pieces together to be able to make that 2026 landing on the moon. I hope you're enjoying this extra long length episode of Space Bites, and I couldn't do it without the incredible team that we have here at Universe Today. Obviously there's Anton, my producer and editor, but all of the stories that I'm talking about, we have writers at Universe Today that are actually covering these different stories. We are a completely independent space news journalist company. And we wouldn't be able to do this without the support of our patrons. Now that Google and other companies are rolling out artificial intelligence into their search engines, they kind of don't need the underlying websites. We're seeing a decline in our advertising revenue. Less traffic is coming to Universe Today through the search engines, and this is having a hit on our bottom line. And so thanks to our patrons, we're able to weather these rocky times. But of course, the more patrons that we get, the more space news reporting that we can do. And so if you want to support the work we do, and it's a very important time for journalists now to have direct support from our audience, go to patreon.com/universe today. If you've been on the fence and you're thinking, I really like the work they do, I don't know, I'm busy this month, now's the time. Go to patreon.com/universe today and support the work that we do. Work begins on the Habitable Worlds Observatory. With James Webb now fully operational, we have been speculating about what comes after the James Webb Space Telescope. Now, Nancy Grace Roman comes in 2027, but what comes after that? Originally, the idea was LUVOIR, the Large Ultraviolet Optical Infrared Telescope. It was going to be like maybe a 9-meter, maybe a 15-meter telescope that would be able to directly image Earth-sized worlds orbiting around sun-like stars. NASA did their decadal survey. They decided that no, we probably want to do something a little safer, but still capable of that goal of observing Earth-sized worlds. And so the plan is the Habitable Worlds Observatory. This is going to have a next-generation coronagraph capable of dimming the starlight from the star to be able to reveal the light coming from the planet directly beside it. But there are some enormous technical challenges to make this work. And so this week we learned that NASA has awarded 3 contracts to 3 different companies to start some of the risk reduction, trying to figure out how to solve some of the problems that this mission is going to have. One contract went to BAE, and they're going to be working on an ultra-stable optic system so that it can gather the light over the long periods of time that's needed to be able to reveal this faint planet. Lockheed Martin is going to be examining integrated infrastructure, which is a very vague term. I'm not really sure exactly what they're going to be doing. And Northrop Grumman will be working on ways to reduce stray light that is coming into their optical system so that they can make sure they're just getting the light from the planet and not from the star or other things that are in the field of view. So these are sort of some of the biggest technical risk that NASA has identified, and they're looking for ways to solve that. And then we will see like a larger design come together and then construction. We're still at least a decade away. Some exciting updates on dark matter. All right, so I want to take a break from all of this spaceflight news and focus on dark matter. And there's a couple of really interesting stories that we're watching this week that I think are going to help you fill in pieces of your understanding about dark matter. So let's talk about dark matter. Like one of the key insights into dark matter, we don't know what it is, but whatever it is, it doesn't seem to interact with regular matter except through gravity, or itself except through gravity. In other words, you could have dark matter particles in a giant cloud pass directly through each other, and none of the particles are going to be bonking into each other. That's very different. If you have giant clouds of gas, they will actually collide and heat up, and you can see evidence of these gas clouds colliding. Stars are very similar to dark matter. They can pass each other, they're going to fly light years apart from each other, and none are going to collide, or very few, when galaxies come together. The classic example of this is the bullet cluster, where dark matter has passed through itself, and you can still see the gravitational lensing of where the dark matter is concentrated. And so observations of the El Gordo supercluster, this is a giant cluster of galaxies seen at a time when the universe was dramatically younger than it is today. Astronomers have looked at it in many different wavelengths. They've used Hubble, James Webb, Chandra, ALMA, and in a new paper, researchers say they're seeing a hint that dark matter is actually self-interacting, that you're seeing some concentrations of dark matter in places that you wouldn't normally see. And so you wouldn't get this unless there was some kind of interaction between the dark matter beyond just the gravity. And this is like the first finding in the most extreme places, one of those tip of the iceberg kind of scenarios. And yet if this holds true, then maybe there is a way that dark matter is self-interacting. And this might help explain why we're seeing these gigantic galaxies early on in the universe. Now, if this turns out to be true, then it's going to cause ripples across other theories of cosmology, but it's like an exciting first crack in our understanding of how dark matter might interact with itself. But it's probably not primordial black holes. One of the other main theories for dark matter is black holes. So these are primordial black holes formed shortly after the Big Bang, when you had these regions of higher density and lower density, and maybe places were dense enough that black holes could just form in the early universe, and then they would just be out there. And some theories, you can actually explain all of dark matter just by having these primordial black holes floating around the universe. You don't need a lot of them, they can be very massive, and yet they would explain dark matter. And so researchers looked at the results from LIGO, Virgo, Kagra, other gravitational wave observatories, and said, well, if there are primordial black holes that fit within the detection range of these observatories, then we should see this signal. While most of the black holes are going to be smaller mass, some are going to be much larger mass, and they would be out of the detection range of Virgo and LIGO, some would show up in their results, and they would have a different characteristic than stellar mass black holes that are merging. And they found that there just wasn't enough of a signal in the observation so far. And so if primordial black holes are an explanation for dark matter, it's less than 1% of the dark matter out there. So they could still be out there, but they can't explain all of dark matter. And yet other papers are coming out showing how MOND is less and less more likely. There's a great video that came out from Anton last week about how Cassini data and wide binary data is showing that MOND really isn't explaining the observations that are out there. And so we're kind of back to some kind of particle that probably doesn't interact, but it interacts sometimes as an explanation for dark matter. So dark matter is running out of places to hide, but it still is hiding very well. Now, while you're watching this enormous video, I am working on an equally enormous email newsletter, and that's because we've got just a ton more stories that we covered over at Universe Today this week. For example, James Webb is rewriting astronomy textbooks for the first billion years of the universe. Metal is being 3D printed on the International Space Station. And NASA has a new database to predict meteorite hazards for spacecraft. So if you want even more space news that we didn't have time to get to in Space Bites, sign up to my weekly email newsletter. It's completely free. I write every word, and there are no ads in the newsletter. So go to universetoday.com/newsletter to sign up. Now I'm going to talk some more about Starship, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, David Giltonen, Dennis Alberti, Dustin Cable, Jeremy Matter, Jim Burke, Jordan Young, Josh Schultz, Modso, Paul Rohrbach, Stephen Krasaki, Stephen Feiler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. Well, what can I say? This was an incredible week for spaceflight. I mean, to see Starship take off, go to orbit, re-enter the atmosphere, to be able to see a live view of that re-entry was really amazing. And even though this test didn't demonstrate complete, full reusability, it didn't land back at the launch platform, the re-entry heat was clearly a problem. There were some problems with the engines. It was enough of a success to say, okay, these are solvable engineering challenges. And I think that probably the next test, like if they do recover the booster safely, if they are able to get to the point that they can land Starship and not have it destroy all of its heat shield and its grid fins, then I think we're at full reusability for a two-stage rocket. And we don't know what this means. I mean, what does it mean to have a rocket that you don't have to destroy every time you launch it? That you can put enormous payloads, heavier payloads that have been ever sent to space, that you can refuel rockets in space and send them to other planets. Now, I personally don't think there's a big need for humans to go and live on a city on Mars, but I think there is a big need for spacecraft missions, new telescopes, scientific operations, communication satellites, people to go to the moon for research stations, and even people to go to Mars for scientific exploration of Mars. And so it does feel this week that we turned a corner, crossed an important milestone, and this will probably be the week that will be remembered as the time when that fully reusable rocket future began. All right, we'll see you next week.